The Big Bang Theory was first proposed by scientists in the 20th century, but it has struggled to address important questions regarding the universe's origin. For centuries, humanity has gazed up at the night sky, full of questions about the mysteries of the cosmos, evolution, and expansion. However, new discoveries have made this mystery even more complex. In 2023, NASA's James Webb Space Telescope made an astounding discovery by detecting celestial objects that appear to be older than the universe itself. This revelation has left scientists perplexed, raising questions about whether a star could have existed for a longer period than the universe. Could this challenge our current understanding of the cosmos and suggest the need for a new model to explain this paradox? If you want to stay up to date on the latest news from the universe and beyond, be sure to subscribe to our channel, like this video, and enable notifications. The mystery of Methuselah star. Approximately 200 light-years away, in the constellation Lyra, lies the star HD 14283. It has a surprising speed of 4,483 kilometers per second, providing insight into a dramatic past. About 1 billion years ago, when the Milky Way was still forming, it collided with a dwarf galaxy, which became home to this star. The star is among the oldest celestial objects we have been able to observe, earning it the nickname Methuselah, a reference to the biblical figure who, according to legend, lived for 969 years. Initial estimates placed the star's age at an astounding 16 billion years, but more recent calculations suggest it is approximately 14.46 billion years old, with an error margin of 80 to 100 million years. This age discrepancy poses a significant puzzle when compared to the universe's estimated age of 13.8 billion years, based on observations of the cosmic microwave background. How is it possible for a star to be older than the universe itself? This paradox calls into question our knowledge of stellar ages, the precision of our dating techniques, and even the actual age of the universe, encouraging further research into these cosmic mysteries. Understanding the age of stars. Determining the age of celestial bodies is a challenging task. Astronomers rely on minute variations in a star's brightness and color over time to estimate its age. Because stars like our Sun maintain their size and warmth for billions of years, astronomers compare these findings with mathematical models that predict stellar evolution. One method, known as gyrochronology, analyzes the rotation rates of stars of different ages. By observing how slowly a star rotates, astronomers can estimate its age. Methuselah is the oldest star in the cosmos that we can reasonably estimate. Rather than focusing on whether it is truly more than 2 billion years older than its surroundings, we might consider another possibility. Could the universe be older than scientists previously thought? It is difficult to comprehend 13.8 billion years, but if we were to condense the entire history of the universe into a cosmic calendar, the Big Bang would appear as the most spectacular fireworks show on New Year's Eve, while Earth would emerge only at the very end of the year. In contrast, human history would span only the last 10 seconds of December 31st. Scientists calculate the age of the universe by observing light from stars that formed hundreds of millions of years after the Big Bang. As the universe expands, a phenomenon known as redshift occurs. By measuring both the observable distance and the expansion of the universe, scientists estimate its age to be about 13.8 billion years. However, new research from the University of Ottawa suggests that the universe may actually be far older, around 26.7 billion years. University physicist Professor Rajendra Gupta offers a theory that blends more recent concepts with Swiss astronomer Fritz Zwicky's 1929 tired light theory. Gupta suggests that protons lose energy over long periods, challenging the conventional redshift interpretation. His reinterpretation could increase the estimated age of the universe and provide answers to long-standing cosmological questions, such as those raised by NASA's James Webb Space Telescope. Gupta combines the evolutionary interaction constant, initially proposed by theoretical physicist Paul Dirac, with the tired light theory. This suggests that cosmic interactions may have changed over time. While astronomer Edwin Hubble proposed in the 1920s that the universe was only 2 billion years old, our estimates have since improved significantly, more than doubling the universe's age. The role of dark matter in the universe. As astronomers refine their understanding of the universe's age, intriguing discoveries about our own galaxy continue to emerge. Recent research on the Milky Way reveals that stars in the galaxy's outer regions travel significantly more slowly than those in nearby areas. This raises two possible explanations. 1. The amount of dark matter, an invisible material essential to a galaxy's gravitational structure, may be abnormally low in our galaxy. 2. Our current understanding of dark matter and its role in the cosmos may be fundamentally flawed. Astronomers have had to reassess their assessments of stellar behavior, particularly regarding stars in the Milky Way's outer regions. The speed at which stars move is a crucial indicator of a galaxy's mass, since gravitational force depends on the total mass of a galaxy. This conundrum arises from data collected by the European Space Agency's Gaia satellite, which provides detailed information on the positions of nearly 2 billion stars in the Milky Way. Recent studies suggest that the amount of visible matter in our galaxy may have unexpectedly decreased. According to Gaia satellite data, the Milky Way's total mass, including gas, dust, stars, and dark matter, was estimated to be about 200,000 billion times the mass of the Sun. However, determining a galaxy's mass is notoriously difficult, and uncertainties in the data may exist. A new era of cosmic exploration. As new information emerges, we will continue to stay informed and update our understanding of the universe's origins and evolution. These revelations challenge everything we previously thought we knew about stars, galaxies, and the very fabric of spacetime itself. The hypothesis that stars like HD 14283 may be older than the cosmos suggests that our assumptions may not be entirely correct. The age of the universe has long been a source of controversy, and as technology advances, so does our ability to test these theories. If evidence continues to suggest that the universe is older than previously thought, our methods for determining its age may need to be revised. This could have significant ramifications for our understanding of cosmology and the origins of everything. We are still far from knowing the exact age of the universe, as recent astronomical findings, such as Methuselah's age and the continuous measurement of cosmic expansion, indicate. If dark matter is less common than believed, it would fundamentally alter our understanding of galaxy formation. With each new discovery, we move closer to answering the questions that have puzzled humanity for centuries. But every answer leads to new questions, fueling an endless cycle of discovery and exploration. Whether you are a seasoned scientist or simply fascinated by the wonders of space, there is always something new to learn.